So guys, you all know that there is no way we can know what should be the right page for this video. This page, maybe the next page, or maybe the next page. Yeah, this may be better because of course you know this little trick, right? When you look at this picture on the left, it could be a girl or an old woman, depending where you focus. And that is called local property. And the same here. You see, when you look at the whole picture, you may see the skull, and when you focus on eyes, you will see faces there. So it could be completely different picture. Amazing, isn't it? And the same here. Okay, you could see a vase, or you could see two faces looking at each other. So again, there is no way we could know which page we can open it to take the video, but that's not important. What's important is look at the fringes. You see the fringes. And this is physics class, so it's a physics problem. And what you need to do is tell me how tall is the book, basically on the right now. Okay, how far this page is from the level of the table. And this is one problem. The other, you see how this fringes bent on the right, on the left page. So you need to roughly tell me what's the curvature of the page. And on the top of it, if you hold this camera long enough and make this video long enough, you will see that these fringes are moving from the bottom of the page to the top of the page. And if you are wondering what the setup is, I'll show you. Okay, so here is this window. Obviously there is a sun on the other side, and sunlight comes in, and you could see this fringe at the very bottom already moved on the page. So you wonder what time is it now? Well, I wonder too, because this camera shows me only local time of that video, and it doesn't show me the reference time, global time. It's somewhere around 11 a.m. and still maybe it's not good enough to determine some coordinates in the space, in this 3D space, not mentioning 4D space, which is plus time, space-time. And I don't even want to say it, but apparently I have to, space-time mind continuum, which is 5D space. So for 5D, you need to know what kind of thought this guy has in his head. And that's still maybe not enough. And again, remember, it's absolutely irrelevant what he is saying. What's important for us is to see how this fringes move along the page towards from the bottom to the top of it. And obviously you understand that the sun behind this window is moving, and as a result the fringes are moving too. So whatever the guy says is not important for the first two tasks, but for the third task it might be important, because if you want to find his coordinates in space-time mind continuum, you need to know what that freaking mind has inside, what kind of thoughts. And again, it will be only global, I mean only local thoughts, right? And the same like this time. You see now it's 5 minutes already of blah 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 blah, because there is no single formula yet. Well, if I write the formula, and that guy can write you the formula how you determine the curvature of the page and the height, or let's say, better say, well, let's call it height from the table to here, to this page. Okay, well, it's interesting to observe would be if, let's say, we have ideal situation. Instead of the sun, we have an ideal source of light that produces these fringes, and we know the speed with which it's moving away from the page, from the book. And we turn this and we measure how the shade is shifting at pages with different pictures. Theoretically, nobody can prove yet. I'm talking about both theoretically, experimentally, that the speed or velocity of the movement of these fringes will not be a function of what's on the page. Because in ideal situation, if you think about the ideal space, okay, and by the way, as you can see here, it's the last fringe that shifted on the page, and it's already 7 minutes long, but it's my mistake. Should have taken a shorter book, would have seen much easier how it moves. Okay, well, faster, let's say. So here some pictures, right? You understand what this guy is trying to say, that it could be, it's a hypothesis that is very difficult to prove experimentally at the moment, that velocity of shifting of these fringes will depend what's on the book, on which page he opened the book. This is a hypothesis. You want to argue with this, please do. I will not, though. If you want to check it experimentally, that's a different story. And if you can have the experiment like that, that will be fine. And I have no doubts that people in the future, and I couldn't say which distant future or not that distant future, will develop this means to measure. Instead of arguing about space-time mind continuum, they will do those experiments. And they will measure, and if they determine that the velocity of this movement of the fringes depends on the pictures, on the content of the page, that will be really freaky. It will be almost the same. That is a real story, which Dr. Z heard on the radio. It's maybe read it. No, it must be NPR radio, where there was a lab at Princeton. At Princeton, they had a lab where they were studying supernatural phenomena and supernormal, abnormal phenomena, whatever. They were studying this people who have extra sensory ability, and the way they were trying to analyze it, they said, okay, here is a generator of random numbers, random number generator, and you try to affect it with your wheel that it spits out not random numbers. The lab finally was closed by the government closed it, but the director of the lab, I've heard it with my own ears, that the director of the lab said it was a mistake because they found that these extra senses, people who have extra senses, they change the randomness of these numbers. It's freaking unbelievable. Just imagine someone stares at a semiconductor chip and tells it, hey, behave differently. And then they said it affected it statistically significant. I wish I had that, because I could give it as an example, that data, as an example to the students who study statistics, and let them verify the data that came out. Are they random, completely random, or really people with extra senses were able to change that pattern, which is amazing. Okay, so you see how these fringes are moving, and it's already 12 minutes, and we came to Salvador Dali. All right, so okay, and think about this just as physics. This is a physics experiment, right? Physical experiment, physics and metaphysics at the same time. It depends on which part of experiment you focus. If you still focus on determining the curvature of the page, is one. Or if you want to determine the height of that step from the table to this page, it's another one. Or if you want to determine the height of these steps, come on, focus. Okay, all right. And I see that it will be difficult for you to see. Well, sorry people, the camera is not that perfect, it's just a normal cell phone. Okay, but think about this 3D effect. That's an illusion to begin with, right? How in the world you look at 2D picture and you see 3D, and look how I can change the curvature. Haha, nice, isn't it? Very nice. Look. Where do you think these fringes are coming from? The small ones. Do you have an idea? Well, here's a clue for you. Okay, so where is it? Oh, right there. You see the shades? Obviously from the screen protector, right? There is a screen on the other side. Right there, there's a screen. Okay, so these small ones, which you can see now better. Sorry, you cannot see the mesh that clearly. But the small ones you can see better, right? Let me see if you can see them. No, still, oh, now you can see them. Okay. All right, so they will be, the accuracy of your measurements will increase if you use the small ones to measure the shift of the shadows. So it's a game of shadow, basically. You know interferometer, right? You know that scientific device they use. The principle is different, but also there are fringes, and they measure the shift of fringes to determine the height of the step. Well, this is much more simple device. In fact, there is no any. Okay, but we have the effect, the desirable effect we do have. And we'll just go through this. Cosmic wheels. Colored pencil drawing. Can you believe that? The super master of masters, drew it with a pencil. This is incredible. Yeah. You see, he started with relatively complex things, like oil and all other things, and moved to some basic stuff. All right. That is incredible. Look at that formula. Yeah. You know, do you see the formula? Well, it says E equals mc squared. And then he put yeah, look at that idea for the impossible ring. That's incredible. You see how easy he showed it by selecting the right order of Roman numbers. Just incredible. How a simple solution. You know, of course, they have this impossible, Möbius loop and a ribbon, and here is just on a donut, basically, by showing the numbers instead of showing. Yeah, he changed the shading to a little bit. Wow, very nice. Nice, very nice. He did it with colored pencil. That's unbelievable. Well, Dr. Z somehow forgot about this. Yeah, this is a famous one. Well, it's not Dali, it's already Sandro Del Prete. And maybe it was at the beginning of his yeah, we missed this. Sorry, people. Apologize for the mistakes, but it doesn't matter, right? For our experiment, it's no difference. But look at this guy with a pencil. He did it better than other people do with paints. Wow. Well, it's already 18 minutes. So basically the first fringe crossed the whole page, let's say in 20 minutes. And the page is roughly 11 inches, well, 28 centimeters roughly. So from here you know the velocity of movement of these fringes. And of course I could have waited for the last fringe to go through and then show you the picture without these freaking fringes. I'm sure that makes your perception different, but here is just incredible examples. Well, we'll come back when the fringe is gone and see what happens. And this is just beautiful. Yeah, Yes, we'll come back.